Welcome to Alpha Insights. I'm Lane. Today we're looking at a less flashy but really important piece of the AI infrastructure puzzle. Joining me is Jonathan, market analyst who follows data center tech. Remember, if you have questions as we go, you can ask us at stockalpha.ai. Markets are open today, so there's plenty happening in the background. Jonathan, great to have you.
Thanks for having me, Lane. Glad to be here.
So to kick us off, what exactly is this company doing with photonics? And why should people who follow AI hardware care?
At a high level, POET is focused on packaging optical components right at the wafer level, basically bonding tiny light-based parts to standard silicon and fiber substrates. The practical takeaway is that this lets data centers use optical links without ripping up existing server designs. So it's not about reimagining the whole stack. It's more of a pragmatic bridge to bring optics into racks and between servers.
Interesting.
Yeah. The reason this matters is bandwidth and power. AI training clusters are gobbling up network capacity, and network teams are pushing link speeds from 100 gigabits per second into 400 and even 800 gigabits per second. Optics scale that bandwidth with far less heat than copper, and they can cut conversion steps that add latency between GPUs and accelerators.
So optics do two things, less heat and lower latency. That sounds straightforward, but is the tech proven beyond the lab?
POET has been showing prototype modules and working with system partners on joint demonstrations. Those rack-scale demos are important because procurement teams at big cloud operators want to see something that can be installed, not just a lab result. Analysts note that vendors who enable optical links at the board and module level are the next step after chip makers and switch makers pushed faster link speeds.
Right.
And to add to that, POET emphasizes lower coupling losses, quicker assembly, and smaller form factors in their demos. That translates, data suggests, into lower per-port power and potentially lower latency versus copper interconnects.
Got it. So the promise is real, but
But there are hurdles. Manufacturing yield and scaling production are the obvious ones. Wafer-level photonic packaging at high volume is still a relatively new manufacturing discipline. I mean, when you look at the data, consistent high yields matter for margins. If production doesn't ramp quickly, this stays expensive and adoption slows. Systems integration is another big piece. Optical modules have to work with existing power delivery, cooling, and monitoring in data centers. That requires co-engineering with server makers and switch vendors, which takes time.
So it's not just the chips or the optics themselves, it's the whole ecosystem.
Exactly. And the ecosystem includes component suppliers, laser makers, and large volume packagers. Companies such as Lumentum and Applied Materials have roles in scaling the supply chain. Hyperscalers have incentives to move faster because optics can reduce energy per bit and simplify cabling for big clusters. But entrenched copper solutions and legacy procurement cycles slow things down.
Interesting. Honestly, I was a bit surprised by how many moving parts there are beyond just the photonics.
Yeah, it's a systems story more than a single component story. POET's pragmatic focus on packaging is smart because it addresses a practical bottleneck that's often overlooked in commercialization.
What should listeners who follow market moves take away from this? Any implications for broader market sentiment or for the suppliers in this chain?
Analysts note that if packaging vendors can prove repeatable manufacturing and secure partnerships with server OEMs and switch makers, photonics could move from niche to mainstream in data centers. That would shift where value accrues in the supply chain, more to packagers and component suppliers who solve the integration problem. That said, sentiment today is cautious. Momentum indicates interest, but people are watching for reliable yields and real system deployments.
For clarity, we're not saying anyone should buy or sell anything here, right?
Right. This is informational only. Analysts are observing trends and risks, not issuing personalized advice. The key is to watch execution, production ramp, partnerships, and demonstrated deployments at hyperscalers.
Before we wrap, quick reactions. What surprised you most in this space?
How pragmatic some vendors are being. Instead of promising a complete architectural overhaul, they're offering drop-in-ish solutions that play with current designs. That practical approach could speed adoption if the manufacturing side is solved.
Nice. All right, let's give our listeners 3 quick takeaways.
Sure.
Key takeaway 1.
Photonics addresses immediate bandwidth and power constraints in AI data centers by enabling much higher link speeds without the same thermal cost as copper.
Key takeaway 2.
POET's wafer-level packaging approach is pragmatic, aimed at integrating optics into existing servers, but adoption depends on manufacturing yield and systems integration.
Key takeaway 3.
Watch execution, production ramp, partnerships with OEMs and switchmakers, and real rack-level deployments are the milestones that matter.
Great stuff. If you have questions about anything we discussed today, you can ask us directly at stockalpha.ai. We answer listener questions live. And for more market insights, head over to stockalpha.ai. Thanks for listening, and thanks, Jonathan.
Thanks, Lane. Appreciate it.